Good morning everyone. Today we are going to see about set language. First let us see the abstract of it, history of sets, then meaning of sets, some of the examples, notes and notations, types of set, set operation, Venn diagram and then references. First let us see the history of sets. Set was discovered by George Cantor. In mathematical structures can be regarded as sets. Next, let us see the meaning of set. A set is a many that allows itself to thought of as a one, said by George Cantor. In generally, we say a set is a well-defined collection of objects. Let's see some of the examples of sets. First one is the collection of all books in a library. Next, the collection of all colors in a rainbow. Next one is the collection of prime numbers from 1 to 100. Here the pink color refers the prime numbers. Next let us see a question. Which of the following are sets? First one, collection of natural numbers, collection of English alphabets, collection of good students in a class, collection of states in our country, collection of beautiful flowers in a garden. Here, which of the following are sets? Here only three are sets. First one, collection of natural numbers, collection of English alphabets and collection of states in our country. These are sets. Other two are not sets because it may vary from person to person. Next let us see the notes and notations of set. Elements of a set are written within the curly braces. Elements of a set are listed only once in a set. Elements of a set are denoted by small letters and capital letter is used for denoting the whole set. A is equal to set bracket 1, 2, 3. This is the example for that. Then if X is an element of A, set then X belongs to A. Then if X is not belongs to A, then we write it as X does not belongs to A. The order of listing the elements of the set does not change the set. Next, let's see the types of set. First one is empty set or null set, singleton set, finite set, infinite set, equivalent set, equal set, subset, proper subset and parse set. First, let us see the empty set or null set. It is also called as void set. Empty set, from the name itself we know that it contains no elements. Let's see the example for that. A is equal to x, where x is an odd integer and is divisible by 2. We know that odd integers cannot be divisible by 2. So it is an empty set. We will say denote it by pi or open and close curly braces. Another example is the set of all integers between 1 and 2. Next let us see a real life example. Here in a basket 6 fruits are there. In the second set there is no fruits, which is an empty set. First one is not an empty set, second one is an empty set. What is the meaning of cardinal number? Here I have given cardinal number is equal to 6 for the first figure and cardinal number is equal to 0 for the second figure. In the first figure, cardinal number is equal to 6. That is, the number of elements in a set is the cardinal number. Next let us see the singleton set. A set which has only one element is called singleton set. In a set only one element will be there, that is a singleton set. This is the example for that, the set of all even prime numbers. So only 2 is the even prime number, so it is written inside the bracket. It is a singleton set. Next let us see what is a finite set. A set with finite number of elements is called finite set. It has an end. For example, a set X is a factor of 36. The factors of 36 is 1, 3, 1, 2, 3, 4, 6, 9, 12, 18 and 36. So we can count the numbers. So countable number of elements is called finite set. Next let us see what is an infinite set. Infinite set is opposite to finite set. Infinite is nothing but we cannot count the numbers. Uncountable number of elements will be there. For example 5, 10, 15, that is the multiples of 5. It has no end. So it is an example for infinite set. The set of all points in a line. This is also an example. Next, let us see what is a equivalent set. Equivalent set contains same number of elements but the objects will be different. For example, here I have inserted an image. First, 6 triangles are there. Next, 6 smileys are there. Next one, 1, 2, 3, 4, 6 star is there and 6 heartin is there. So, the number of elements are equal but the elements are different. So, it is equivalent set. Here I have inserted another example. Here 3 rounds are there and 3 cubes are there. So, the numbers are same but the objects are different. That is equivalent set. Next, let us see what is the equal set. Two sets are said to be equal if they contain exactly the same elements. Exactly same elements will be there but it can be either in a different order. That is, for example, A is equal to 1, 2, 3, 4. In B, we have written it is in the descending order. So, both the sets are equal. So, it is a equivalent set. This is a real life example for equivalent set. Both the images are same. Next, let us see subset. Next type is subset. Let A and B be two sets. If every element of A is also an element of B, then A is called a subset of B. We will denote the subset by this sign, A subset of B. This is an example for that. 1 is a subset of 1, 2, 3. It is from the image we have written this. Next one is proper set. Proper subset. Let A and B be two sets. If A is a subset of B and A not equal to B, then A is called a proper subset of B. A is a subset of B. Example, if A is equal to 1, 2, 3 and 1, 2 and 5, B is equal to 1, 2, 3, 4 and 5, then A is a proper subset of B. That is A subset, proper subset of B. Then let's see what is a power set. Power set is denoted by P of A. The set of all subset of a set A is called the power set of A. Here I have inserted the example for that. Then let's see some of the set operations. First one is universal set, complement of a set, union of two sets, intersection of two sets, difference of two sets, symmetric difference of sets, disjoint sets. Let's see one by one. First, universal set. A universal set is a set which contains all the elements of all the sets under consideration and is usually denoted by U. It's nothing but the elements of all the elements, that is A, B, etc. Everything will be included. For example, if A is equal to Earth, Mars and Jupiter, then the universal set is the planets of the solar system. We can say it as an example. Next one is complement of a set. The complement of a set A is the set of all elements of U that are not in A. Complement is nothing but if we have an element A, universal set is there. What is the meaning of universal set? U is equal to all the elements. All the elements means, for example, I have said that solar system. In that A is Earth, Mars, Jupiter. Likewise, we have given here. So, what is the universal complement of a set here? A complement. A complement is nothing but the elements which are not in A will be written in A bar. Here it will be denoted as A bar or A complement. In simple we say it like this. A bar is equal to A dash is equal to X belongs to universal set, X does not belongs to A. Then union of two sets. Union of two sets is nothing but if two sets are there, A and B, then union of two sets is nothing but the elements of both the sets. It should be, the elements should be from A as well as in B, but it should not be repeated. Then intersection of two sets. Intersection of two sets is the set of all elements common to both A and B. Here common elements will alone be taken. For example, in the set A we have 1, 2, 3 and 4. In B we have 3, 4, 5 and 6. Then here the intersection of two sets A and B is 3 and 4. Next let's see the difference of two sets. Difference of two sets is nothing but A difference B. That is the elements of A will be included and the elements of B will be excluded from that. That is difference of two sets. Then symmetric difference of sets. Symmetric difference is nothing but A delta B. A delta B, the formula for that is A difference B union B difference A. This is the formula for that. Here I have given an example. A is equal to 1, 2, 3 and 4 and B is equal to 3 and 4. First we are finding A difference B, then we are finding B difference A, then we are taking union for both the terms. Then disjoint set. Two sets A and B are said to be disjoint if they do not have common elements. If they have no common elements, then they are said to be disjoint sets. If we have common elements, what will we say that? It is an intersection of two sets. Next, let us see the Venn diagram for all the things. First one, complement of a set. First, this is the Venn diagram for complement of a set. Second image, A dash. The A portion which is red in color is the complement of a set in second diagram. Next, first one, union, intersection, difference and symmetric difference. These are the Venn diagram for all the four set operations. Union means, what is the meaning of union? All the elements of the set, that is A and B. So we are shading A and B, both the elements, both the terms, both the circles we have shaded. Then intersection means common element. Here common element comes in the center alone, that red color portion alone. So we have shaded there. Difference means A difference B. How will we say that? The elements of A will be included, then B will be excluded. So we haven't colored the portion B. Symmetric difference, A delta B is equal to A difference B union B difference A. That is given here. Next, these are my references and thank you.